So I'd like to apologize to those of you who bought the ticket to see my friend Steve Took, who couldn't make it. So I'm a stand-in for Steve Took, who was in the original program. He's a colleague of mine. So today I'm going to talk about sub-second acceptance tests. This is a topic that's very dear to my heart. If it isn't dear to your heart, I'm going to try and convince you why it should be. That'll be the first part of my presentation. And then I'm going to give you a demo, and then we can have a chat. How does that sound? All right, cool. So a bit about myself. I've been a programmer for very long, I think 20 years or something, professionally. Before that, I did Commodore 64 stuff. What else? Yeah, I got involved in the Agile community around the time that the Kent Beck's book came out, and then shortly after, I was involved in behavior-driven development. I guess my claim to fame is I invented a tool called Cucumber 10 years ago, which I'm still the benevolent dictator of. Right, so a lot of people use, so the reason I'm interested in fast acceptance tests is that people have taken this tool and created really, really slow acceptance tests, which is kind of sad, right? Because everybody blames me for Cucumber being really slow. But it is Cucumber is actually really fast. It's just a tool. Depends on how you use it. So I'm going to try and teach you some tricks that you can use to make things faster. Even if you're not using Cucumber, whatever testing tool you're using, the techniques that I'm showing you today should be applicable. Whether you're using JUnit or NUnit or robot framework or whatever. So before we get into the details, I'd like to tell you a little bit about why this is important, to have really fast tests. In 1994, that's a long time ago. Some of you probably weren't born in 1994. But there was a book that came out written by a guy called Jakob Nielsen. Who's heard of Jakob Nielsen? Right. So he's considered to be one of the gurus and one of the founders of user experience as a field. So this is a book about usability engineering. How do you make software that's easy and friendly for humans, right? Human-computer interaction and that kind of stuff. And in this book, there's lots of things in this book. I haven't read the whole thing, actually. But I've just been made aware that one of the things that he talks about in this book is that there are 3 time limits to keep in mind when you're optimizing application performance. So imagine that you are creating some sort of software with the user interface. There are 3 time limits that you need to be aware of. And this is, by the way, this is based on research, and this is the numbers that I'm going to tell you about. They were discovered in the late 60s, and it hasn't really changed. So the first time limit is 100 milliseconds. So 100 milliseconds, that's the limit for an average human being to feel or to get the perception that the system that they're interacting with is reacting or responding instantaneously, right? You cannot really distinguish between something that responds with it instantaneously or 100 milliseconds. It feels pretty instantaneous. If you've ever been on a video chat, I'm sure you have, you start noticing the lag beyond 100 milliseconds. That's when it starts getting annoying, okay? But it just feels like it's instantaneous. It's 100 milliseconds. So for the people who design user interfaces, there's nothing you need to do. If you can respond that fast, you don't need to put up a progress bar or a scroller or anything, or spinner. Just display the result. The next time limit that Jakob Nielsen talks about in this book is, can you guess? 1 second. Okay, so it's leap, an order of magnitude every time. So this is the limit that allows a user's thought to stay uninterrupted. So they might notice that there is a delay, but you can stay focused on the task at hand even if it takes a second, right? So you still don't need spinners and visual feedback if it takes a second to respond. But the user kind of loses the feeling of operating directly on the data. Okay, so it's a bit different from 100 milliseconds. Now, if you follow the pattern, now what comes after 1? So the previous one was 100 milliseconds, multiplied by 10. So the next one's going to be 10 seconds. So that's the third limit that Jakob Nielsen talks about. And now we're moving into more dodgy territory. This is the limit for keeping the user's attention focused on the dialogue. Okay? So if you're doing something, you're interacting with a computer or the computer system, and the feedback takes longer than 10 seconds, you're not going to be able to stay focused or concentrated on whatever you were doing. Right? Imagine you're I don't know, you click send, and you don't, the computer doesn't tell you what's happened until after maybe 15 seconds. Well, by 10 seconds, you're already off reading Hacker News, or maybe you're going for a coffee break, or you start doing something else because you just can't stay focused. You're not going to sit looking at the screen for more than 10 seconds. So what do we do instead? Well, I'm sure you've all seen this cartoon here. Whoops. You start doing other stuff. And this cartoon here is about compilation, but it isn't just compilation that takes time. Running tests takes time as well, especially if you've written them poorly. So I'm going to talk about a few other books, and then we'll get more techy. In 2011, this book came out. It's a book about psychology. It's written by a guy called Mihaly Csikszentmihalyi. I think that's kind of the best I can pronounce that. Has anyone heard of this book? It's called Flow. There's another great book called Flow, which is about lean manufacturing and that kind of stuff. It's not that kind of flow. This is like the mental state of flow. Now, in this book, the author, he talks about, or he writes about, rather, certain conditions that need to be present in order for a human to achieve a state of flow. Now, what is a state of flow? Well, state of flow is that you have this experience of intense concentration, right? You're intense and focused on the present moment. You're not thinking about other things. And you get this merging of action and awareness. Like you can't really distinguish. And you kind of stop thinking about yourself. You're thinking more about what you're doing. You stop worrying about whatever worries you might have in your life because you're so engrossed in this thing that you're doing that that's all that exists in your mind. So you have reduced ability to recognize yourself as an individual separate from what you're doing. So that's one of the things that describe this state of flow. Another thing that happens is that you get this sense of personal control or agency over the situation or the activity that you're doing. And there's many things. You kind of lose track of time. Have you experienced that? You're just working and you're like, oh, it's 6 o'clock, right? And you got into this state maybe 4 hours ago and you just didn't notice. Time just flew. And the last thing is that clicking a bit wrong here. And you have this autotelic experience. Now, what does autotelic mean? It basically means that you get the experience that whatever you're doing is intrinsically rewarding. You kind of just, I don't know, endorphins are just rushing to your brain. You just love it. Another book is by a woman called Kendra Cherry. She's a psychologist. She also describes flow. It's a sense of having immediate feedback. And this isn't just about programming, right? It can be sporting activities. whatever you're doing, you get feedback on what you're doing almost immediately. And you're feeling that you have the potential to succeed in whatever you're doing. And you need to have that instantaneous feedback to do that. And you're so engrossed in the experience that everything else becomes completely negligible. Okay? So this is the state of flow. And why is this important? Well, I think it's important in order to do anything well. You know, you need to be in this kind of state. If you can never achieve this kind of state in whatever you're doing, you're going to perform whatever activity you're performing. You know, you're not going to do it very well. It's going to be quite inefficient. But when you get there, you get into this experience, which I'm sure maybe you have experienced when you're programming. You're in the zone. Raise your hand if you've been in the zone. See, everybody's been in the zone. That's why you're here at this conference, because you love programming. But what keeps us from getting into the zone? What is it that prevents us from getting there? Because we've all been there, but I don't know what it's like for you, but for me, it's quite difficult to get into that state of mind, because there are so many things that get in the way. People coming up and talking to you, that's one thing. But if we think of the more technical things in our work environment, what is it that stops us from getting into the zone? Well, back to what Jakob Nielsen talks about, it's feedback cycles that take several seconds, right? If you type something, you make a change, maybe you do a refactoring. If you have to wait more than 10 seconds from you finished your last keystroke until you know whether that was a good change or not, you're going to completely lose track of what you were doing. And you know, when you come back to it, you're like, where was I again? Have you experienced that? Yeah. So, and that's why it's incredibly important to have really, really fast tests. If the tests take multiple seconds, you're never going to achieve a sense of flow unless you just stop running the tests, right? But then you've got you know, some other problems to deal with. So it is important to have sub-second or you know, preferably sub 10 millisecond speed of your tests if you want to get that fast feedback and get this sense of mastering the situation. Your tests have to be really, really fast. Now, tests quite often aren't very fast. So what has the community come up with to address that problem? Anyone knows? Well, lots of things. One of the things that people have come up with, Mike Cohn came up with this, and it's been popularized by Martin Fowler. It's called the test pyramid. Who's heard of the test pyramid? About half the room. So the test pyramid is a guideline basically telling you that it's a guideline about the proportion of different kinds of tests you ought to have in your bag of tests. So what it's saying is that you shouldn't have that many UI tests because, well, it says here, testing through the UI is slow and it increases build times. And tests that run end-to-end through the UI are brittle, expensive to run, right? And time-consuming to run, well, expensive to write and run. So, but we all know that unit tests, you know, they can be isolated from everything, and they can be really fast. So we can have loads of those tests. And then we'll have somewhere in between, you know, with these things in the middle called service tests, whatever that is. And this, I don't know, I can't remember exactly when the test pyramid was introduced, probably in the early noughties. It's been around for 15 years. And I've thought for a long time that this is a brilliant idea. But lately, I've started to question it. And I've come up with, well, I'll tell you why I've started questioning it. Because I think, you know, the idea is, you know, sounds like a good idea, right? But there's a hidden assumption here in the argument for the test pyramid. And that is the assumption that UI tests are slow, okay? So it isn't really that we want to have few UI tests, we want to have few slow tests. And because UI tests are slow, according to conventional wisdom, we're going to say we're going to have few UI tests. But what if UI tests weren't slow? Would we still recommend this? Or would it be different? So I got an alternative to this. I call it the test speed pyramid, which is similar, but I'm not making any assumptions about what kind of tests are slow, medium, and fast. Okay? It is true that most UI tests that you come across are slow because they're just written in a stupid way. Sorry. They could have been written better, is what I meant to say. So I'd like to make a slightly weaker statement and say, yeah, we will have few slow tests and we'll have lots of fast tests. But we're going to try and make the UI test be slow just as the unit tests. Now, let's have a look at a typical test harness with, let's take a web application, right? So a web application consists of, at the bottom, you've got a database, and you've got some business logic. I'll get a drawing here, actually. So down here, you've got a database, you've got some data access object, DAO, some domain logic, and then a bit of HTTP API, maybe some sort of Spring Boot or Express or Rails or whatever. And then you've got some HTTP. And then the orange stuff, that's your client. So maybe there's a React app or a Vue app or something. And it talks to HTTP through this client here. And then it runs inside of a DOM. You've got a browser. You've got WebDriver or Selenium. And then you've got the tests. Yeah? So you've got all these layers here. And I'll get back to why what these jigsaw things mean. But for now, just think of this as, this is your stack. This is your full stack UI test that goes all the way from the test and down to the database. By the way, the colors here, they mean something. Green is test code. Red is infrastructure. It's the stuff that needs to be there, but it isn't really our code. It's just other stuff. Orange is the front end, and blue is the back end. Okay? Just I'm going to show you different variants of this diagram, so it's just useful to keep that in mind. OK, so I could have drawn this in a different way. I could have drawn this with a hexagonal architecture diagram. Who's familiar with hexagonal architecture? All right. If you're not familiar with hexagonal architecture, write it down and go and read about it, because that is key to understanding how that works. Is key to decoupling a system so that you can have fast tests. I chose not to use that representation for my illustrations because, well, the principles that I'm trying to get across, I think, fit better with this kind of model. But it's the same idea. But let's look at why is this test suite slow? I said, one test here would take, roughly 10 seconds to run. Could be faster, could be slower, but around 10 seconds. But why is this test slow? Why does it take so long? Because if we want to make UI tests faster, we have to understand why they're slow. OK, well, I'm going to ask the question differently. An automated test is a program. Is that a fair statement? OK. So if we think about computer science, the computer scientists, they talk about how programs can be slow, and that they say that they are bound by something. And there's two main kinds of boundness that a program can have that will make it slow. It can be I/O bound. Right. So a program that is I/O bound is a program that will go faster if you add a faster network, okay? And then there's another kind of bound, CPU bound. That means if you add a faster processor or parallel processors, the program will be faster, okay? So is this slow because it's I/O bound or CPU bound? I/O. Well, there's always one bottleneck that's the biggest one, and I think in most cases it's I/O bound. But there are going to be, if you remove that bottleneck, if you remove I/O bound bottleneck 1 and 2 and 3, maybe then you get to CPU bound, right? So where is the I/O in this picture here? Well, let's start from the top. Let's say that let's say that this is a Node.js or JavaScript program. So my test is written in JavaScript. But I'm using Selenium or WebDriver. Well, WebDriver, Selenium, that's a Java program. It has a protocol. So my test is talking over a socket here. Okay? And WebDriver needs to talk to the browser. Now, I might, I'm not entirely sure here if there is I/O here. But there's definitely a lot of stuff going on in here, which is CPU bound. Then we're talking to the DOM. So there's no I/O here. That's all running in the same process. The React app is kind of running, in the DOM, so no I/O here. Nothing here either, but here we got I/O. As soon as we're going to make some API call, there's I/O here. And hopefully this stuff is all in the same process, and then we've got I/O down here. So we've got a fair amount of I/O going on. Now, what if we can remove some of these bits that are slow? Let's see if we can remove Selenium, because that's known, in my experience, that is one of the slowest things in this kind of test suite. So I'm going to remove it. I'm going to pull that out, and I don't know if you saw what happened. Those fancy, I stayed up till 4 o'clock this morning making this animation. So I'm just going to play it a few times. See that? It's great, isn't it? Thank you. I've got more of them. I got like 4 more of them. Okay, but so what happened? So we took away Selenium and that thing that was on top of it, and then we plugged something else in, which I've called the DOM actor. And so it's the same test, but we removed some things. Is this test going to be faster? Well, yeah, it says 1 second, not 10 seconds, so it's faster. I measured it. I'll show you in a minute, or maybe 15 minutes. All right, but we can do better than this. What else can we remove? What else is slow? RDBMS? That's in like 3 slides, but we'll get to that. Well, we'll just remove a bit more. Oops, I removed HTTP. See that? I removed this. Boom. So what I did, I removed the API client and the HTTP, let's call it just the HTTP routing on the server side. And what I've done now is I've connected the front end directly to the back end. Like, they're now communicating with method calls. OK. Word of warning. You can only do this if they're written in the same language. But in this case, this is the backend is written in Node.js, and the front end is written in, well, the backend is written in JavaScript running on Node.js, and the front end is written in JavaScript running in a browser, normally. But in this case, I'm running them all in the same process, because I've completely removed HTTP. And that's possible if I'm careful about having clear contracts and interfaces between things. I can just wire everything up a little bit differently. So when I'm clicking something in the React app, that's going to go straight to the domain logic and run stuff. So I can remove even more things. Now we're removing the database. And we've just got some sort of in-memory fake thing that provides data. And now there's no more I/O at all. All of this stuff runs in the same process. But I've got all the essential bits here. Where is the interesting code in this application? Well, it's probably in the React app and then the domain logic. And everything else is just translating from one format to another, translating from HTTP back to JSON and back again. And so we removed all of these things that don't really have the logic of the application. And now I can run tests in 10 milliseconds, or sometimes faster. And we can make it even faster, right? I can say, well, I'm going to remove actually all the DOM stuff. I'm just going to test the domain logic. But what about the other front-end stuff? Well, actually, I can have 2 test suites where I can run the same test in this configuration, just testing the back-end code, and I can run it in this configuration, just testing the front-end code. And now I've got really, really, really fast tests that can run in around a millisecond, 1 to 5 milliseconds is my experience on this MacBook here. So to summarize, these are all of the different things that I've shown you. On the left here, you've got the full stack, really slow, tests that give you confidence, but they give you confidence about the integration. They give you confidence that you've wired everything together properly. And because they're so slow, they're going to run in 10 seconds. How many of those tests can you have? Not that many. So it's going to be really hard to build confidence that all of your application logic is good if you rely on these kinds of tests. They're just going to take hours and hours to run, and you're never going to get in the zone, and you're not going to know until the next day that you've broken something. It's just a horrible experience. And I feel sorry for those of you who have to deal with just those kind of tests. On the other side, you've got really, really, really fast tests, right? We're talking 3-4 orders of magnitude faster. That's a lot. You can have many of those. They're super fast, but they give you a different kind of confidence. They give you confidence that your functionality, your logic, your company's edge, whatever your company does that sets it apart from other companies, that logic is working. So the idea is that, you've got loads of these tests over here, a few of those in the middle, and very few of those. But it's a different way to partition the amounts of different kind of tests that you have from what the testing pyramid is telling you. Because all of these tests here are acceptance tests. In fact, if you look at the top of these things, it's the same test. I'm running the same test in 6 different ways. But it's the same test. How is that possible? Well, just by using, what is it? Bob, is it the Liskov substitution principle? I think so. There's a contract between the test and those things sitting underneath it. And that's this line here. So the tests themselves are decoupled from the system under test. It doesn't really know what it is interacting with. It's just interacting with a contract. So the test knows nothing about buttons or text fields or forms. Knows nothing about databases. Knows nothing about implementation detail, to be honest. All it knows about is some sort of contract that is specific to whatever domain you're in. So I'm going to give you an example of a word guessing game. But this contract is basically just some methods that has to do with this word guessing game in this case, or a photo sharing app if that's what you're building, or I'm sure some of you are doing more interesting things. And the interesting thing about that is that because there's a contract here, what would happen if your test says things like click this button, go to this link? Well, that means that your contract is now tied to a user interface, which means you wouldn't be able to plug in something like this, right? How do you click a button on a domain logic? It doesn't make any sense. So you're forced to writing the tests in this more high-level language, talking about the business domain rather than the implementation. And that's something that I've been trying to make users of Cucumber do for about 10 years. And it's such an uphill struggle because there's just so much misinformation about how to use this tool, which is all about clicking buttons. But please just stop. So we got a reusable test, okay? It's reusable because it doesn't make any assumptions about the implementation, and it's reusable in the sense that it can be reused to test the same system in different configurations or assemblies, as I call them. So let's have a look. All right, so I'm just looking a bit into a bit more detail about this, this contract here. So the test, what does it do? Well, it pokes the system with domain-specific commands. So for example, in this guessing game, you can guess a word, steak. So that's one of the methods on this actor here, which is basically an abstraction of the system. And then when it's going to make assertions, well, it's going to ask the same thing to get a list of guesses that have been made in this game. And that returns, some sort of domain-specific representation of the state of the system. And we can make assertions on that. And those assertions, they happen up here. But they're done on what I call a test view, which is just, you can think of it as a projection of this system that we sort of tucked away behind this facade. All right, let's have a look at a demo. So I'm going to start up this little app, little Node app. I'll give you the link so you can go and have a look at the code. So it's a two-player game. It's really fun to play with kids. So there's a code breaker and a code maker. So the left one here is, oops, sorry. Why don't you tell me? Let me share this. Let me do the, apologize for this. I'm going to do the, displays, mirror displays. I've done that several times before, and people always get a kick out of not telling me. Mirror displays. Yeah. Get you in the zone. Can you see now? All right. Okay. All right, so I got these two browsers here. They're connected via WebSocket and some stuff. So I'm going to think of a word here, maybe steak. Okay. So now this user is now waiting for somebody to join the game. So over here, we're just going to say join game. And the server will sort of like find a game to join. Okay. So now it's this player's turn to guess game, so I'm going to say hello. Okay, now this other player is, so it's like a turn-based game. So I can see that the user here guessed hello. So now we need to score it. So how many out of steak is my secret, how many correct letters were there? 1, E? Right, 1. So, okay, so I'm just going to say 1, score. And now, it's a terrible UI, but, okay, so now my guess is scored, and I can continue. I can say boring. Right, and then we can continue like that. Okay, so it's a very simple game. So I've got some tests for this. Let's run them. And in fact, I've got loads of tests. I just copied the tests, because I've only got like 15 tests or something, but I've copied them just to demonstrate what it looks like when you have many. So what I'm doing here is I'm running the same test over and over again, but in different configurations. So I'm starting with the really fast ones. All right, let's just scroll back a bit. So this is the one where I'm only testing the domain logic. So I'm only testing the server-side code, right? So I ran 48 tests in 39 milliseconds. So that's about 1 millisecond per test. It's pretty fast. And that was an acceptance test for validating the domain logic, just shortcutting the UI. That gives me a lot of confidence that that logic is good, right? Now, I want to know if the UI works. So I just wire the system up in a slightly different configuration. Now I'm actually just testing the UI. But I'm not going through Selenium. I'm running the Chrome the Chrome DOM inside of Node, you can do that with a library called Electron, which is what people use to build rich GUI apps at the moment. Like if you've ever used Slack, that's essentially Node.js with a Chrome browser inside it. So we're using that same thing, and that allows us to run a DOM inside of the same process as, basically lets us run the front end in the same process as the back end. How long does that take? A little bit longer, like 3 times longer, 4 times longer or something. So I don't know, maybe 5 milliseconds per test. Okay. That's a lot worse, but it's still pretty good. Okay, now I'm mashing them up together. So now we've got DOM plus HTTP, but still running in the same process, but it's going over HTTP, probably through some sort of loopback interface. And you see it's increasingly slower, but it gives us more confidence, because every time I add a little bit more height to my stack, I get more confidence about the, that I've integrated everything correctly. And finally, so hang on, this was just HTTP. And then finally I'm running everything, and it takes 13 seconds to run all of them, so I don't know how much that is per, that is like, I don't know, you can do the math. And what I didn't even do here is use Selenium, okay? I didn't even implement this in Selenium, but if I had done that, it would have taken probably 10 times as long. Running this test suite would have taken me probably, a minute or so, at least. For how much more confidence? A little bit, but not that much. It'll find bugs like, oh, the cause headers on the server weren't properly set and stuff like that, but it's not going to go through a different path of the code. It's not going to discover other things. So I'll show the code briefly, and then we'll skip to some questions. All right. So let's have a look at the test themselves. So this is a cucumber scenario. So as you can see, the words that I'm using here for the test have nothing to do with implementation detail, right? It's almost like how I would explain the rules of the game to a kid by just giving some examples. So, for example, when the maker has started a game with the word silky, and the breaker joins the game, then the breaker should be told that, yeah, there's 5 letters for you to guess, right? And it's illustrating different kinds of rules here. Here, for example, the breaker's joined the maker's game. Breaker guesses pant. But then you should get some sort of message saying, hey, there's got to be 5 letters. Because it's always, the rules of the game is that you need 5 letters in your guess, and so on. But nothing about implementation detail, like what the UI looks like or anything. And that's what allows me to basically decouple the test from the implementation. So we can look at the step definitions behind here. And again, if you haven't seen Cucumber before, might not be too familiar with it, but it looks like this. So this is basically the code that sits behind this text. So you got the test. So you can think of this as the test, and then it's interacting with the actor, which is this thing here called breaker, right? And I've got another one for maker. But the thing is, I've got different implementations of this class. I've got one that interacts with the DOM by clicking buttons and stuff. I got another one that just talks HTTP. I got a third one that just goes straight to the domain logic on the server, and I could write a fourth one that uses Selenium. But I completely decoupled the test from the system and the test through this contract. And that's pretty much it, because I only have 45 minutes. And if you want to learn more about this stuff, you can study the code. If you want to create your own diagrams, you can go to that second link. And if you want to, and you should go and see this excellent talk by Nat Price who spoke at the QCOP conference, which is my conference, or my company's conference, last year. Same topic, but he's explaining it much better than me. So I'm happy to take some questions.
Hello. I think we've got time for probably just one question, then we have to break, unfortunately.
All right. Yeah, it's a great question. Let me just go back here. So the question was about the test pyramid isn't just about speed. It's also about flakiness. What's quite common is that UI tests are flaky. So what I could have done in here is I could have created a flakiness pyramid, and you should have few of the flaky ones and many of the non-flaky ones, or be a little bit more rigorous, deterministic and non-deterministic. Now, what is it that makes a test non-deterministic? It's essentially two things. One is that you don't control all the data. Okay? You're connecting to some other system that you don't control, so that makes them non-deterministic. And the other thing that makes them non-deterministic is that you've got race conditions. Now, if you manage to decouple your application in the way that I demonstrated, you can remove both of those problems. You can remove the reliance on external data sources because you're just using interfaces and dependency injection and all these decoupling techniques throughout your entire stack. So you control the data, and also because you're removing all of the I/O, you've also removed most of the common causes of asynchronicity, which is what leads to non-determinism. So yes, this is a simplification. You could just make a version of this called the determinism pyramid, and say you'll have few of the non-deterministic ones and many of the deterministic ones. But again, UI tests don't have to be non-deterministic.
Okay, thank you.
All right, thank you.